examine the consistency of the system equations. Now here, we have a system of linear equations, two variables. We just note down the coefficient matrix. Let us first rewrite it as the coefficient matrix 1, 2, if I speak column wise, 1, 2, 2, 3 multiplied by variable matrix xy equal to 2, 3. Even for solution it has to be written like this. And now to the coefficient matrix, if I denote symbol A, that is 1, 2, 2, 3. So it is A, the quotient matrix, will decide whether it is consistent or not. Though I have already discussed in the previous class, but I repeat, in case the matrix A is non-singular. What is a non-singular matrix? That determinant A is not equal to 0, then we will comment that the system is consistent with unique solution. In other case, in case determinant A is 0, then there may be two possibilities. It may be, inconsistent with no solution, or may be consistent with many solutions. So that I will discuss in the next questions. Now in the present case, what is the value of determinant A? The determinant A is, the product of the right diagonal, 3 minus 4, negative 1, obviously not equal to 0. So we comment that as determinant A is not 0, the system of linear equations is consistent with unique solution. So he is not asking you to solve, just the consistency is to be checked. Next question. 2x minus y equal to 5, x plus y equal to 4. Again you rewrite in matrix form 2, 1 minus 1, 1, xy equal to 5, 4. So what is the quotient matrix? If I denote it by A is, the matrix is 2 minus 1, 1, 1. What is the value of determinant A here? Determinant A is 2 minus 1, 1, 1. If you work out, you get 2 minus minus plus 1. 2 plus 1, which is 3, and of course not equal to 0. So we should comment that the system of linear equations is yes consistent with unique solution. It is consistent with unique solution. Next, question 3. It is x plus 3y equal to 5, 2x plus 3y equal to 8. Put it in the matrix form, 1, 2, 3, 6, xy equal to 5, 8. 5, 8. Okay. Call it one. Now what is the quotient matrix? Let me rewrite it as Ax equal to B. Here A is the quotient matrix, that is 1, 3, 2, 6, and B I am calling to the constant matrix. Now find the value of determinant A. Determinant A is determinant 1, 3, 2, 6. When you work out determinant, it is 6 and minus 2 into 3, 6, 0. So yes, in this particular question, we find determinant A is 0. So we can't decide at this stage that whether the system of linear equations is consistent or inconsistent. Let me here redefine. There will be two cases. Now you have to work out the value of adjoint A into B, the constant matrix. In case this is not equal to 0, then the system will be inconsistent and it cannot be solved with no solution. But case 2, if we find that adjoint A multiplied with B is also a 0 matrix, then of course it is consistent, we can solve it with many solutions. So that will be the criteria. So let us work out in the present case adjoint A. What is adjoint A? It is the transpose of cofactor matrix, each element to be replaced by cofactors. So you know the sign convention, plus minus, minus plus. So for the main diagonal elements, 1 is to replace by 6 and 6 by 1 with the same sign. So here you get 6, 1. For the other diagonal elements, you just rewrite with the change sign. For 2 it is 3 with the change sign minus 3. For 3 it is 2 with the change sign minus 2. And take transpose of it. So you get adjoint A equal to, take the transpose. So 6 minus 2 you write in the first column and minus 3, 1 you write in the second column. So now we have worked out adjoint A. Work out the value of adjoint A into B. Remember, adjoint A has to be on the left. B is the constant matrix. So it is 6 minus 3 minus 2, 1 matrix to be multiplied by matrix 5, 8 in the present question. Now let us see, can we multiply or not? The first matrix is of order 2 by 2. Second is of the order 2 by 1. So yes, because the number of columns in the first is same as the number of rows in the second, we can multiply. And how do you multiply? Elements of first row to be multiplied by the column, and you get 30 minus 24, and then similarly you multiply the elements of second column with the row, so you get minus 10 and plus 8. So you get matrix equal to 6 minus 2. Of course, this is not a zero matrix, so what do you conclude? That as determinant A is 0, but adjoint A into matrix B is not equal to 0, so the system, hence the system of linear equations is inconsistent and has no solution. With no solution. Next part. Examine the consistency of the system of linear equations. This time it is a system of linear equations involving 3 variables and 3 equations. Though the basic method will remain the same. Now before I proceed, let us see here in the constant, the third equation, you have an arbitrary constant A, and it is not mentioned whether A is 0 or non-zero. It will make a lot of difference when we decide finally. But A cannot be 0, though even if it is not mentioned, A cannot be 0. Why? Because if I take A as 0, so it will be 0 plus 0 plus 0. On the left side it will be 0 equal to 4, which will totally be false. And after all, it is a given system of linear equations, it can't be false. Okay, so A is non-zero. It is as good as given. Write it in the matrix form. You get 1, 1, 1, 2, 3, 2, A, 2A, multiplied by the variable matrix X, Y, Z, column matrix, and the constants 1, 2, 4. So we write it like this. Now let us work out the value of determinant A. First of all, what is the coefficient matrix? A. It is 1, 1, 1, 2, 3, 2, A, 2A. So let us work out the value of determinant A. Determinant A is determinant 1, 1, 1, 2, 3, 2, A, 2A. How do you work out the value of determinant A? Okay, we can work out with respect to any row or column. So if I work it out with the help of first first row, expand with R1. So you get 1 time, delete the row and column through 1, you get 6A minus 2A, that is 4A, 1 time 4A, and minus 1 time, delete the row and column, you get 4 minus 2, so minus 1 time, so you get delete the row and column, you get 4A minus 2A, so 2A, and then plus 1 time, delete the row and column through this one, you have 2A minus 3A, that is minus A. So you get 4A minus 2A minus A, so that will be equal to A only. Now as A is not equal to 0, I mentioned Y, so we can conclude that determinant A is equal to A, which is not equal to 0, so the system is consistent consistent with unique solution. By unique solution you mean that if you solve, you will get only one set of values for x, y and z.